Well, hello everybody. Welcome to Omachini's channel. First of all, I have to give some shout outs to some people who have given me very valuable feedback. Thank you very much. Thank you for watching and thank you for supporting me. One is Dr. Dark and the other one is Pritz. And I really appreciate your feedback. I try to do everything that you have mentioned. And that is why I actually am making this video. I am explaining about the things that I assumed to be known in the first video that I created, so that everybody can actually follow up and understand everything that I'm talking about in the video. I have experienced some technical difficulties today. The recording just wouldn't record, so I'm just redoing everything that I did today and ripped the past half hour that I just spent explaining everything. But that will actually help me to explain this time. It's very much better. So, the thing is that in a computer, when we want to code, we need to understand how everything works actually behind the scenes also a little bit. So I'm going to start with the very basics. We have in a computer a CPU, which is connected through a data bus to a RAM. Okay? And then the CPU is also connected to other things. It might be connected to an HDD, connected to a GPU. The GPU is then connected to a monitor. And of course it's also connected to I/O devices, input-output devices. Things like the keyboard and the mouse. The thing is that in C#, as in many other languages, we need to actually tell the CPU what we want it to do. This computer is actually a very, very stupid tool. It doesn't know anything from itself. It just knows what you tell it to know. And it also just does what you tell it to. Even if it is not what you want, if you tell it something very stupid, it will just do it. The thing is that through the IDE, through the C# coding language, I have direct access to the CPU and to the RAM, and I can tell the CPU exactly what to do. The CPU does things for us then, and the RAM is a temporarily storage solution. It just stores some data, some values, some whatever I want to manipulate and work with temporarily for us in there. Why temporarily? Because if you restore the computer, everything that was written in the RAM will be deleted. The HDD is a more permanent solution to store data, but it's terribly slow. That's why generally we have direct access to the RAM and to the CPU. Everything else, the GPU, the I/O devices, the HDD, we do have access to them, but not direct access to them from the coding environment. We can access them through some libraries, but the CPU and RAM I can directly manipulate without any needs of any libraries and anything else than the coding language itself. If you had paid attention to the first video that I made, I wrote some codes, and you will definitely see lines like this, like int var1. What this line means is that I tell the CPU to reserve a place, a playground for me in the RAM. So what this line actually does, in the RAM, it will go and reserve a place for me, and it will name it var1. So whenever I want to work with this place that has been highlighted into the RAM, I just use the handle var1. And this part, this int, it tells the CPU how much space it should dedicate to me and what I can store into this variable. I have various options here. It can be var, it can be int, it can be decimal, it can be bool, it can be string, it can be char, and every one of them has a different meaning. Actually, if you look here, there's a pretty good table of the default variables that I can use. Why default? Because through some libraries and through my own coding, I can actually add data types. But these are the hardcore basic ones, and these are the ones that can be used without any need of any library. I have bool, which is a Boolean value, which means only 0 and 1. It's only 1 bit. I'm only getting 1 bit of the RAM for this variable, and I either can store true, 1, or false, 0 in it. That's it. Then I have byte, which is an 8-bit unsigned integer. This 8-bit means I'm actually getting 8-bit of the RAM for myself. And because of the 8-bit limit of this variable, I can only store values from 0 to 255. Not even negative value. That's actually the unsigned. Unsigned means that I cannot store negative values to it. That's it. If I try to store 256 into a byte variable, I will actually get an error in the runtime. Then we have char or char, which is a 16-bit Unicode character, which means I can only store 1 character in it, not a string, not a text, just 1 character I can store into this variable. We have decimal, which is only decimal parts with 28 significant values, but I cannot actually store floating points values. I mean, I cannot store values which have decimal values after the comma. I mean, I cannot store 10.1. I can only store 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or this kind of stuff. And I can all go up to 7,9 times 10 power 28, which means I can have it for 28 or 29 significant digits. We have double, we have float. In float, I can actually define floating point type, which means I can have values after the comma. I can store 10.1, for example. I can also do it in double. Double is 64-bit, which is a huge number. It can be really huge, and you can see that here pretty much. And but for float, it's a single precision floating point type. It means I can only have 1 significant number after the comma, so 10.1, but not 10.12. For that, I need to store it actually into double. We have int, which is an integer type, which can be negative. That's what's called signed. It can be negative or positive, but no comma. Just values like 1, 2, 3, 4, 5. And we have long, which is the double of the size of integer into RAM, which is 64 bits. You can see it can store a much higher and larger number. And a fun fact is that in YouTube, the count of the views that a video has got used to be int. So it could count up to 2 billion views. But the video, Gangnam Style, got actually more than 2 billion views. So they had to change the entire data structure of YouTube, of the view counts, to long, so that the number could be saved in there. And imagine this, that how huge the database of YouTube is and the viewing counts it has. Now you have to change this huge data structure, which will put a lot of strain on the servers themselves, because you need the double of the memory needed for the viewing counts now for the longs. Of course, it's just the viewing counts, so it might not be that huge of a difference, but for a scale of YouTube, it's actually pretty huge. And we have some other types which I will not go into because they're not very significant right now. So, as I was saying, int, this part, means that what type of data I can store in. And this part was actually the handle that I can't use. So if I write int var, then in the next one I write var1 equals 1. First of all, you need to know that the CPU goes through the lines with the succession. So first it will does this, then it will does this. Do or does? I don't know. I think it's do. CPU will do. It sounds will do. Of course, it doesn't need the S. Well, forget about it. So, whatever happens is that here in this line, I tell the CPU to store the value 1 into the space that had been reserved for this variable. After this line, if I look into the RAM and try to see what the value of the RAM of this part that had been reserved is, I will actually see the number 1. Of course, the reason that we are using variable names, it's very difficult to address a part of the RAM, so we are using names to make it easier for us. Now, the thing is that I can also make a lot more than just one variable for myself. I can make, for example, int variable 2, and I can write this var 2 equals var 1. Now, what happens in this line is I tell the CPU to copy whatever it sees in the space of variable 1 and transfer the values of variable 2. So whatever was in variable 2 will be deleted, and whatever now is in variable 1 will be copied to variable 2. And as you might have guessed by now, after this line I will have no access, I will have no access to whatever the previous value of variable 2 was. It has been completely destroyed, gone forever. So you have to be very careful, because this line is very different than this line. This line says copy value of variable 1 into variable 2. This line says copy the value of variable 2 into variable 1. So, actually, whatever happens here is that after this line, because variable 2 already has the value of variable 1, nothing special will happen, even though the CPU will actually copy the value from variable 2 to variable 1. So, now I want to see a couple of examples of this usage of copying the values. Imagine I want to write a program where I store whatever the user has written into the command prompt into a place in my RAM. If you don't know how to actually access the things that the user has written through the command prompt, watch my first video. There I explain it and I write the hello world program. Now, if I want to store the value that has been written, if I assume that the user will only write numbers, I can do this. I can define a variable, and I can say variable 1 equals console.read line. This is a function. This function will read whatever is written in the console from the keyboard with the I/O. This is actually the part that I said that with some libraries, I have access to keyboard, and this is one of the libraries. Console is one of the libraries which gives me access to the keyboard. So it will read a line, waits for the user to press enter. Whenever the user had pressed enter, whatever has been written in the console will be copied and stored in variable 1. Great, now I have access to it. Now, the question is, why did I did this? Why did I have to store this? Imagine this scenario. I want to actually see what the user has written, if it is actually a number or not. And then I want to add something to it, and then I want to multiply it. But if I don't write this line, if I just write this, this will actually work. It will tell the CPU to wait for the user input. Whenever the user has pressed enter, then it goes to the next line. Okay? Imagine in the next line I say there one something. Okay? Now, the data has been destroyed. Why? Because here I got the value that had been written in the command prompt. But because I didn't store it anywhere, I have no access to it whatsoever. The data has completely been destroyed in the next line. But if I write this, the data will be stored into the variable, and now I can do stuff to it. For example, I can say variable 1 equals variable 1 plus 1. How can that happen that I have both sides variable 1? If you have paid attention, you know that this line means that whatever is written here will be transferred and stored into here. Here, this command tells the CPU that read the value of variable 1, add 1 to it, and the result should be stored in variable 1. Now, in the next line, if I use variable 1, I will not have the value stored here, but the one here. So, if I write right now console that write line var 1, if I run this program, okay, it wants a number from me. I press 2, then I press enter, for example. What will be printed out? Here, the answer of this will be 2. After I press enter, here the answer of this will be 2. 2 will be stored in variable 1. In this line, variable 1, the value is 2. 1 will be added to it and stored into variable 1. Now I want to print whatever it's written in variable 1. What is it? It's of course 3. That will be printed by the CPU automatically. So now I know some basic stuff. This line reserves a place for me to play with. This equal means copy whatever is on this side to this side. Okay? And that's the basic thing of using the CPU and the RAM for some basic stuff. So variables actually means RAM. I can use that for data storage, from temporal data storage, again to point out. So now I want to give you a small quiz. Try to write a very small program that takes two numbers from the user, adds them, and prints them. Okay? You can pause the film and try to write it. I highly encourage you to do. If not, the answer is going to be like this. First, I have to define two variables. I can do it in two ways. I can say int variable 1, comma, variable 2. Alternatively, I could also write it like this: int variable 1, semicolon, int variable 2. Both of the lines are exactly the same. Then I need to get the input from the user. So I write variable 1 equals console.readline, and variable 2, I forgot the semicolon, variable 2 is console.readline. That is for the second input. So I have here the first input, here I have the second input. Now, both of the values are of course saved into in these variables. Now I have again two options. I can either say int sum equals to variable 1 plus variable 2, and then console dot write line sum. One possibility. The other possibility is to actually, I'm going to separate it like this, to just write console dot write line var1 plus var2. This will also actually work without any need of defining a third temporal variable. It depends. This side, it's very good for debugging. It's a very vital step of programming. It's very necessary, and it's usually very difficult to find where the problem is, because as I said, the CPU, the computer, it's very stupid. It will do exactly what it tells you to, and sometimes when you tell the CPU to do stuff, you want it to do something else, but what you actually have told the CPU to do is something else. And when this happens, shit hits the fan. Yeah, I got it right. Shit hits the fan, and then you need to start finding the shit where it happens and try to debug it. This one is more compact. It makes the code a little bit smaller, maybe also a little bit more readable, but the debugging will be a little bit more difficult, and you will see in the future why. Now, I have a question. Can I write it like this? var1 equals var1 plus var2 console.writeLine var1. Will this work? What do you think? Will this work or not? Yes, this will work, but it's not a good practice. The reason why it's not a good practice is because it's not very readable. I have defined variable 1 as the first user input. Now I'm storing the added value in it. It makes the debugging much more difficult, and it's highly discouraged that you use the variables like this. The common practice, the good practice, is to define the variables, the names of the variables, exactly by their purpose. Name them what they are supposed to do. For example, in this example, it would have been better to actually define the variables like this: int input 1 and input 2. This will make the reading of the code at a later stage much more easier, much more better. And never, ever, ever reuse a variable for something completely unattended for its purpose. Like, for example, using input 1 to store the sum of it. It will make it so much more difficult to understand and reread your code and debug it afterwards. Okay? This is based on my experience that I this should be actually enough for today. You should understand right now what variables are, how I can store them, how I can manipulate them, and how do I work with them. If still there are some questions, please write it in the comments. I will explain in the next video, of course, whatever it is. This is part of the Q&A video. And yes, I hope you have enjoyed it, and thanks for your support. Again, if you like my videos, subscribe. My name in YouTube and in Twitch is both Omechini, and you can see it here. And actually, I will upload today as well a new episode of the series C#, and I will actually write my first program there. Yay! So I hope you've enjoyed it, and I hope to see you soon again. Have a very nice day. See ya. Doesn't stop. Yeah.